So, I just pulled Lab 6 out of the rotation. The Basically it's a tutorial, but the tutorial is so old. Um, a big portion of the tutorial is showing you how to set up input and to pass it to a component. And that, but the problem is it's using the old input system, not the new input system. And I don't. It's one of those I really don't know where is this. I mean, this is part of the documentation, but it's now stale. So we're going to move on. We're going to look at triggers, volumes, and events. Um, for the sake of Unreal, a volume can be a trigger. So you'll hear the word trigger. Basically, what player walks into a trigger, something happens. That's usually referred to as a player clip, a player trigger. There are other types of triggers. Like particularly if you're on the Quake side of things, there's triggers for all sorts of things, and there's things such as clips, which basically is a blocking volume for it's a block, but basically a blocking volume. So player clip is something that keeps the player in bounds. A monster clip does that for enemies, and there's other clips as well. There's rendering things that with Quake stuff that you'll see from Quake up through Quake 3 into some of the modern like Half-Life, the Half-Life Source Engine, Source 2 have these clips as well still. Because Half-Life is off of the Quake branch, and we know this because they haven't changed the light code. The flicker for the light is the same flicker from Quake. What doesn't need don't change what doesn't need to be broken. And we know it's a safe flicker, and it's um, I've mapped for Quake, I've mapped for Quake 3, I've done Gold Source, I've done different versions of Counter-Strike maps from 1.6 to ZZ through Source. It's the same light flicker. It hasn't changed. So that's a little bit of your history lesson. The Source engine comes from the Quake branch. Um, Call of Duty is off the Quake branch as well. Far Cry, particularly Far Cry 1. So when we get back close to Far Cry 1, 2, that's closer to the Quake branch. It's spun off from Quake, but it's closer to the Quake branch than you realize. I'm trying to think. What's the big ones? And you can go back and you can look at the id Tree branch because it's pretty massive. There's so many games that have been produced with it. Um, I worked at Raven, and they had historically had worked with id technology for a very long time, and then didn't. At Raven, known for Soldier of Fortune, known for the first Jedi, one of the Jedi Knights games, not the first one. They're known, and then they moved. Then they got they worked with id to do a Wolfenstein game and Quake 4, and that experience broke their relationship. I can tell you that the thing soured because Quake Quake 4, which was a sequel to Quake 2, was using the Doom engine, and that had all sorts of issues. And there are like so many different issues with that project. Quake 4, both Wolfenstein. It was a miracle if Wolfenstein made any money, given how they spent money. Literally, at one point, they basically had to break down the Wolfenstein team. Whoever was who knew Marvel, who had worked on the Marvel team came back. They kept the core crew on the Wolfenstein game to writing the ship, and then they built two prototype teams, and one of those prototypes became Singularity. but that became that was on the Unreal Engine. Yeah, that was a big deal. And the Marvel team after Marvel Alliance moved on to the Wolverine Origins game, and that was done with Unreal Engine as well. So yeah, no, it had gone. I'm sorry, Raven, who had been the big pom-poms of id technology for so long, finally ditched it completely and went with Unreal technology. I was at the meeting when they announced that, so that's weirdness. So history lesson. Um, what? This is so. If you hear me say triggers, in Unreal, they are called volumes. And you've known this, and I'm just going over history. What we haven't. So what we're going to do is we're going to look at on start overlap on end overlap in C++. And our first thing is literally the first thing is we're going to create a C++ class that basically start on overlap is going to put into the console window begin overlap and overlap. We are then going to implement a event, and this is something that the countdown timer I forgot had events implemented into that module, and I basically hand waved it because I forgot about it. So the key here with blueprint events. So basically, we're going to make an event in C++ that could be then called in Blueprint. And the goal here is that by doing so, we can then basically kick off something do something in our code and kick off something that then is picked up by Blueprint to do what it needs to do there. So we're going to do basically I'm going to do I think I'm going to call it either Blueprint. I'm either going to call it so basically they're going to be begin overlap and overlap. And then we will have basically a function, two events, basically player entered, player left. I think I'm calling them on start overlap and on end overlap in here. Actually, that's the names I'm using here. So I'll use these names actually on. And then finally, we'll use the, so we're going to call the C++ code hello trigger. Let me bring up Unreal. Let's just jump right into this. So the goal here is we're going to make basically a basic trigger that we'll be able to throw into the map. We're going to make it functional with user C++ to create the hello trigger BP. And then we'll use a light switch BP. I have given you links to documentation. I usually need to take these out because these are no longer. Epic changed how they do their documentation, and yeah, not helpful. So those links were broken, unfortunately. So, I want to note that this is due on March 19th. So this is basically when we come back from spring break. So it's not a hard lab. It's just we've got spring break next week. So. What's going on? No. I'm just going to ignore this. make sure everything's okay. Did something break that I don't know? Let me just compile my code. What's going on? Third person. Nothing weird's happened to mine. All right, so I had a moment of what the heck was going on with Unreal. All right, let's file open level. Where's my player start? Here it is. So I'm just gonna go. I'm gonna file. Just gonna call this Lab 07. I'm just gonna keep working in here. I'm gonna put the. So here's where the player start is. I'm just gonna flip this around. Move this back a little bit. So I'm going to be looking in this direction, so I can ignore. I'll ignore the rest of the level for my purposes. All right. So let's go refresh. I want to call it. What did I call the class? Hello trigger. Okay. And this is going to be an actor. Hello trigger. Create the class. And I'm going to close all the tabs. I'll come back. Give it a moment to create the class. There we go. Okay, so reload all. There we go. Okay. All right, so let's take a look at. I've given you a link to a begin overlap code, and this is to Romero. This is the Romero blueprints. So I have. So for those who are watching the video, I just pulled out a book. It's called Blueprints Visual Scripting for Unreal Engine 5. And Marcos Romero is one of the authors. So here is the book that I'm talking about. His website basically has a companion website, and there's a table. If you look here, table counts for Blueprint, table counts C++, table counts verse. So basically, he's basically translated the whole book, his book, into C++. He's right now working through Verse, which is the scripting language that's built into Fortnite. But the big thing is that it's an override function, and I'm gonna grab this line right here. It's basically it's a virtual void notified actor begin overlap, and there'll be a version, and then a pointer to the other actor. Project game mode. He's doing. timer thing in here. Yeah, so this is basically what's going on here. I think he's building something related to the collectible game that you guys did or I showed. So basically, the first thing I'm gonna just copy that straight. This is going to be where did he put it? It should be public, but it is public. And then I'm going to grab jump into here and attach it to the class. So let's jump down to here, take a look at where he uses it. I mean, here in this case is basically, hey, begin notify, begin overlap. He calls the parent, and then he's doing things specific to that. I am going to grab the parent here, just to be on the safe side, to make sure that if there's anything, and I can't think of anything that I would need. But this is just good practice that, hey, given with the engine size we're dealing with, there might be something that I'm not realizing off the top of my head. So I'm calling the parent to make sure that any overhead or whatnot is getting done properly. And then I'm just going to take going to throw in C++. So this is basically what I need to get this up and going. I'm just going to literally just grab this function. I'm going to copy it. I know there is a end overlap. And don't worry about it breaking at the moment because I haven't put the... I'm just going to jump back to hello to the .h. And I'm going to do end overlap. So I basically put the two functions again. It's notify actor, but again, this is technology debt. All right, Unreal Engine's been around since late 90s, mid to late 90s. I want to say 97 is Unreal Gold, and Unreal Tournament is 99, which is the same year of Quake 3. So this is Unreal Engine 1. There's still things in this engine that still harken back to Quake to those days. So
first released in 98.
98. Okay. Thank you. It's close. Okay. All right. So let's go with it. So we've got this up and running. Let's get this. So let's jump back to the editor. And actually, let's compile this. All right, so we're all good. So let's now jump into, we're going to make a new open, let's go back to content draw. I'm going to just jump in here. I'm going to basically create a new blueprint class. It's going to be, so we're going to go to the hello trigger class. And this is going to be BP hello trigger. And let's jump in. And let's add, again, we need a cube. And make the scale of this like 0.1. Not on the Y. Sorry. Different engine. I think this is 10. Yeah, it's sitting on the ground correctly now. Okay. Go in, give it a material. We're gonna give it. Use ground mass. The MOS right now. Hooray. Okay. Save, compile. Actually, compile, then save. You should. Let me put this in the correct order. Let's put this into the world. Is it floating? It is. Let's go back to that. Should be 5. There we go. All right. One thing that we want to make sure is that the cube, let's look at our collision. So there's nothing on the DC route. Is there anything up here? Collision. It's the cube that we want to make sure that here's collision. We do want to overwrite the lap events. Again, we want to make sure at the end this is set to trigger. Should be okay. Compile. So let's press play. So you can see right here, you know, begin overlap, end overlap. So that class is working. Now it's not doing anything, and it's, you know, we can't extend it right now because we don't have the functionality. And this is where the events are going to come in. Basically, we are going to add events to the class, which then we can then call in Blueprint. Okay. Let's jump to exposing gameplay elements to blueprints. Making classes blueprintable, and that would be, hey, I can make this class a blueprint. Let's make sure that we do have. Let's just for the sake of argument, let's make sure this is blueprintable in here. Acceptable class for creating blueprints. Default is not blueprintable unless inherited otherwise. This is inherited by subclasses. Blueprint type. This class can be used for variables and blueprints. And I'm actually going to go and I'll just grab that just you know, the heck. Let's make sure that we can make it a blueprint type. So we can add this. Another blueprint can use this type as a variable. So pretty straightforward. It's going through the blueprint. Where is it? See, so it's going through UFUNCTION stuff. We've already looked at this. Here we go. So blueprint to native communication. Blueprint callable. This is a native function that can be called to a blueprint. So we've already seen this. Blueprint here. Then there is blueprint implementable event, and there's a blueprint native event. So we're going to do one of the functions implementable and the other one native, just so you can see the difference between. So the first one, blueprint implementable event, this is actually pretty easy. This is the primary way. Again, you're going to call up the blueprints. So let's go back to our code. So basically, we are creating void on Yeah, begin. And I think I'm going to pass it. I think I'm going to pass it the A actor. We'll come back to that one moment. And then we'll do, the next one is going to be okay. So let's take a look. So on this one, we're going to call, we're going to make this the blueprint implementable event. All right, so now it's going to yell about there's no function here. Don't worry about this in one moment. I'm going to comment this out for one moment. And by making a blueprint implementable event, we don't need to write a function for it. Basically, the U event should ultimately is going to make it this tag is going to allow us. It's going to create an event within internally, but there's going to be no implementation for it. There's going to be no function. Go, it's compiling, and ta-da! So compile complete. So now we can go back into here, go to its event graph. I mean, we're gonna just take these out because we're not using them. And then we can do on there we go, on begin overlap. And we have passed the other actor. So we haven't called it yet. We'll come back to one sec. But here we have now the event. Right now it's not being called, so let's call this. So let's take a look at go back to our code. Essentially, right here is going to be on begin overlap other actor. So essentially, we're calling it like it's basically, again, when we make these events, they're essentially specialized functions. This is going to be important. These events are going to be important later on, particularly for replication. You're going to be doing things going across the server via replication. So later on, when you start playing with the networking side of things, these events are basically how you're going to get across the server. You're going to make an event and then tag it. This is runs on the server only, is reliable. These are things that you would be tagging for the most part. All right. So save that. For our purposes right now, we're just going to go print string. I'm just going to say hello from Blueprint just so we can see that. And then we can go back. Back to the editor, back to the level, press play. And if I run up to it, did I not compile? There we go. There we go. I had not compiled, so it wasn't actually calling the event. So now it is. So you can see hello from Blueprint, hello from BP. And then from the content draw, let me see. You can see each time And you can see blueprint message, hello for B. So you can see the message is happening. So when you have, grab this. So we're going to tag the other one as, where is this? Is the .h. So we're going to bring this one back, and we're going to make this a blueprint native event. Literally what you then need to do is to grab this line of code. Do I need... Actually... No. Hold on. So I've made this a native event. So what happens is that in this case, this is the weird thing with Unreal, is that, let me grab the function definition. Let me attach it to the class. All right, you think this is what you'd be doing. That's not right. What ends up happening with Unreal, there is, you go through and you create a function that is underscore implementation at the end of it. And this is the weirdness about that. So there's stuff that can be going on in here. I'm going to just grab in here. So I'm just going to put in here, C++, and overlap implementation. Just so you can see that in play here. So the idea here is that there is C++ code that is happening on this side, and then there's also a blueprint there's a blueprint version that you then can create. So I've saved everything. Let's go back. Let's compile. And now, let's just make sure this is saved. So if I go in, back to the editor, go to the output log, and here's the end overlap. Why is it? Okay. I'm going to move on. So let's go back here. There is now the event on end overlap. And this is going to be and I'm just going to go in. I'm just going to go in here. I'm going to go in and make a change here because this is very on and end. I'm trying to think. I'm just going to put CPP code on the end of this, just so you can see that, hey, this is different. This is not, so making sure that we are using this specific event. So this is just so there's no confusion so there's no confusion that we are that we're not using these events. Let me compile. Let me just save. Oh, and what I didn't do is I didn't oopsies. I didn't put the CPP code here and the CPP code here. There we go. Oops. Oh, and oh, you know what I didn't do again? I didn't call the end overlap again. That's why I wasn't calling. So there we go. So now we can save everything. Clear that. Let's compile. There we go. And then I'll jump in, jump out. Not the wrong. So you can see end overlap. Let's see. Let's go back to a trigger. And let's there we go. Here's begin overlap, CPP code. Here's the end overlap. Make sure I save this. There we go. And you can see that there it is, running as intended. There's the output log. And I'm not getting the implementation, but I'm not too worried. But here is the end overlap. Yeah, for the most part, ultimately, I mean, like, you are going to use the blueprint implementable event. That's typically what you want to be using. There's only a few cases with the native event. I just want to show you that when you make the native event, you got to basically be able to function that. And I should have, let me go back to code one moment. I should have gone super. Oh, there's no super. There's no. Sorry. I don't have a. I'm not inheriting from something. My apologies. But ultimately, again, this is what you would need to have. You need to implement something native in code, and that ends up having an underscore implementation. All right. So pretty straightforward. Content draw. We're gonna make blueprint class. Again, use hello trigger. BP light switch. The cube. Transform 0.1. Materials. The cobble. And then collision. Here we go. Here's the collision. Set it to trigger. File. And then I need to add a light. So I've got a point light. Drag that up. 250 sounds good. Attach it to the scene root. because I don't want to scale the light. You know, I don't want to. Basically, the cube. I basically when I built it off. It was attached to the cube. Not exactly what I want. In theory, we could take the cube and make it the default scene root. It's just now we've got scaling involved with the default scene root, so that's why I'm not doing that. So yeah, I mean, this is a case of the event graph. And then we're just gonna use set visibility. I'm gonna turn this off on and overlap. Again, making sure we're just gonna do the same thing. I'm just gonna put it up here. And then on what did I call it? My God. There you go. Begin overlap. And yeah, we could go and check on the other actor and see. Again, we can do like say, hey, if it's the player, you know, do stuff. So I'm gonna again, I just want an actor, just something in play, and then content draw, light switch. I'll move this 250 over. Just so that. We need to go to the directional light and intensity 0.5. There we go. What did I do wrong? I didn't turn on the checkbox. This is why we test our code. So don't feel bad when you do stuff like this, because I'm doing it too. All right, back to, and there we go. Our hello world from early on, but now using C++ code and events. And notice that this is further in the ground than that one because basically I didn't move it up 5 units. That might actually look better. Yeah, I might actually go back and turn that. So yeah, I mean, like it is, you know, shoving it in the ground, but yeah, good enough for a level designer. And I can say that because I was trained as one. Just note that the goal here is that why is this important? Is that the goal here is that we are trying to build pieces of our game that the designers and artists can use. So they can go off and that they can do things like we give them a piece of code that they can use in multiple different ways. And this is one of the ways, hey, I've determined something has happened in the C++ side, and there's things I could want to do, and then hey, designers, this happened, do you need anything else had to be done? And this allows you to support your designers, particularly your designers, in ways, you know, and again, this is a very simple example, but this is the idea here is we are putting something together for our designers so that they can use it as they see fit. So that they can, you know, finish what the actual end properties are, And we don't have to worry about that. We don't have to come in and be like, oh, I have to program this or program that. No. It's the idea is making sure that we can give the work to the designers, and that we don't have to be there to hold their hands or to make changes to the code for something very specific that they are doing. We should be flexible enough for them to do what they want. Be mindful. Artists typically don't know what's going on if there's a technical issue. Designers, if you give them a bug that they can exploit, they will. So with an artist, if you give them an inch of space to that, with a bug, they'll play within that inch. Designers, if you give them an inch to play within that bug, they will take a mile on you. And as a designer, I have done this to programmers, and they hate me when and you will know this is your designers. They see it operating as X. X is a bug, and they somehow turn it into a feature. That's welcome to dealing with designers. Yeah, this is this is pretty much what I was looking for you to do with the assignment here. Again, let me see. Yeah, I'm blanking. Yeah, there are any questions? I think the one thing is I don't think there's a native event. I don't think there's actually any code. I don't think it's actually calling this code in here. Oh, I need to delete that. I think it just needs an implementation in the C++ side. I'm not sure it's actually calling. It may. I might be doing something wrong. And it's something in replication will come up where you'll need if there's something. I think if you need to do the implementation, it's because something in replication needs it. But for our purposes, I mean, we're basically. I mean, I could take this all out, change this to blueprint implementable event instead of a native event, and it wouldn't matter. Most of the time, it's going to be blueprint implementable events. There's going to be an odd case where you need to native. I just want to make sure there's weirdness on that side. For the sake of argument, for going through to know that you've done this correctly, do the end overlap event as a native event. Just for the sake, this is academic. I gotta make sure you've done everything. You know this, so I'm gonna ask you to do the native event, do the end overlap as a native event, just so that you have the practice and you know how to go through the hoops to do that. Would we normally, again, back to normal practice, would we normally use that? No, we'd probably just make it a blueprint implement event and off we go. So, but this is our C++ code can do as much as it can, and it's expecting its child classes to do something. This is where the events come in. Those events, and again, they're the same red boxes, so underneath the hood there is an on overlap, end overlap, other events. There's a C++ code. There's C++ there somewhere calling that event. There's something going on C++ already, and we're taking off on our blueprint side. So. Pretty straightforward. Again, we're doing this over spring break, so I'm not, I'm gonna literally upload this video, and then, I'll forget about everything until we come back next week, 2 weeks. So, I wanted to give this lab because it's low-hanging fruit. It's an easier lab. It's not intensive. There's not a lot going on. But it's showing you, hey, here's how we do on overlap, end overlap in C++. and then properly showing you events that I probably should have shown you like 3 weeks ago. My apologies. So, any questions? No. Okay, I'm going to end the video now.